Hi, for today's video, I have an application that I want to go over, and I want to share my database on how I am making this happen. One, for my customer, and two, for the internet. You're welcome. If you're interested in this database or how I did it, or you just want to take a look at it, please feel free to email me or drop me a comment on this video and I will reply back with the database. Awesome. So let's just get started here into the application. This is the scenario that I have. This is an injection molding, blow molding processes all over this facility, and we have what's called a primary and a secondary. So what we are trying to do is communicate these parts that are interchanging constantly with machine. And so we finally figured out a way that we can consistently let their, we call it the red zone, right? The SCADA PLC system know what is on the machine and give a clear, complete signal that that is there, basically. So for you and I, what this really just means is that we've got one radio per machine, and we're just tying in a discrete input to each node. And we've got a gateway somewhere in the middle of, so we can get good line of sight quality. And we have two nodes that are handling all of the outputs. So for example, node 1, input 1, will go to discrete output 1 of node 18. So we get up to 47 nodes. So we are going to use the P8 radios, the -P8 radios, because those have up to 16 outputs. However, the first register is reserved for, I think, a whole bits of summary, basically, on that terminal. So we're actually going to skip on input 1, on the first terminal of these radios, just to simplify for the sake of customer ease of use. So that's all that's happening. Input 1 goes to these outputs, and we're just doing the register mapping, and then we're doing some thresholds here. So this is the layout. We've done a site survey and it works. I've already created the program. It's already opened up here in the DXM configuration software. Notice the title gets uploaded here on the application status bar. And so I am not connected right now to anything. I'm just, for the purpose of this video, going to go over the register mapping, how that worked, and what we have in here. So all of your inputs, this is where I have created basically like a memory map inside your local registers. And so I've taken the first 6 inputs, which is the default setting for those radios. You get 6 in and 6 out. That's the dip switch configuration for those. And I've just kept the same type of addressing. So we're starting off with 17, and I'm placing that into the local register 17 of the DXM gateway. So we're taking those Modbus registers that are in the radio nodes, and we're copying them into the local registers for the DXM gateway. So I did that for all 17 nodes. So those are all the machines that are going to have a radio on them monitoring that input signal. And then I've also got what's called a node 20, 21, 22. And these are going to be reserved for, we'll see here, for the outputs, I believe. On my RTU write registers, we've got the same setup, except we're starting at 25 for those. And you can refer to the data sheet and the formula for all of that. But I've kept the same scenario here, the same mapping. That's all we're doing, is just copying the Modbus register to local registers. I could have come up with a different number. I could have come up with a different scheme there, but that's all we're doing. We're keeping the server ID on both RTU read and RTU write to 1, because that's what we're just talking to performance radios, and we're just keeping it all on that layer. So that is all the register mapping. Everything that I've done in there is all for the register mapping. If we go here to local registers, I've already labeled everything so there's not a lot of confusion. And if I go over to the action rules tab and under thresholds, this is where I created all of my this goes to that kind of thing. So for example, for my first input for node 1, which is 17, if that is equal to a value of 1, I am going to checkbox, make sure these are checkboxed. I am going to turn on local register 290, which is node 18 output 2 to value 1. So I'm turning that on. So I hope that makes sense. If there's a need for on delay or off delay things, we have the hysteresis box here that can help with that. We've also got a few other options here on the DXM software that I'm not using. It's not necessary for this. But that is a gist of this program. So now all we really have to do is make sure that we get connected to the DXM. If it's over a USB cable, it's going to be over serial. If it's over TCP, it'll be an Ethernet cable. So we have those two. As you can see, this is the DXM700 with the 2 ports here up at the top. And if it's USB, usually it's a little easier. You can click the refresh, click the COM port that you're on, connect. You'll see the little application status bar here at the bottom, let you know that it's connected. And you can go to File, open up the database, the program. It's going to be a .xml file. And what you'll want to do, and is I can't click on this right now, but if I were connected to the DXM, I would have an additional drop-down menu here under DXM, and I would send this configuration to the DXM, let it download. You'll notice that the DXM will power cycle, it'll turn on and off, and you will have the program to work with. And also, I want to quickly go over the register view here. If you go to your left vertical menu, you'll see the tools section, and under that the register view tab, where we can actually monitor and just do a little bit of troubleshooting to make sure that the program is actually working. If you go here to register source, we can look at the local registers. That's where we want to be, and we can start at 17 because that's where our memory map started on the input side, and I can monitor up to 40 registers at a time. If I were connected, I could click enable polling and then click begin polling, and I would see in real time every second getting updated whether or not something is on or off. If I want to test the outputs to trigger something or force something on, I can go out here to one of my outputs and I can write a value of 1 and click write register and force that output to be on. And then I could come back over here on my registers and see if that output actually turned on. So that is one way that you can use this as a built-in troubleshooter for this program. I use this quite a bit, and it is helpful when we are commissioning things in the field. So I hope this overview helped you. And if you liked this video, don't forget to give me a like. And if you want the database, drop me a comment or email me. Thanks.